Alright guys, welcome back to Underground Science, and in this video, it's going to be a pretty easy video. I just wanted to go over an example of the auto-ionization of water, alright? Or actually two examples. So it's just gonna be a really easy video again, just a simple calculation, but just to get a really quick overview, I guess, of the auto-ionization of water and how we can use it, because it's going to come in handy when we talk about future acid-base calculations and go into weak base, strong acid titration, strong acid, strong base titrations, weak acid, strong base titrations, and so on. All right, so let's just go and get started. So here we see that we're given the concentration of OH, all right, the OH negative or hydroxyl concentration. So we're given the concentration of our alkalinity of our solution. How do we find the H3O plus? Well, if you remember the auto-ionization of water, we had Kw equals a concentration of OH times the concentration of H3O plus. So all we have to do is use that equation. So the Kw, right, was our concentration of our OH and our concentration times our concentration of our H3O plus. So we just use this equation. So remember, Kw was 1.0 times 10 to the negative 14th, and after that, all we have to do is sorry about that. All we have to do is just multiply or just solve for the H2O plus like an equation. So just feed in 5.5 here times 10 to the negative 4th, all right? And just solve this as H3O plus, right? What's the concentration of our H3O plus over hydronium? And so all you have to do is just divide that now, all right? And when you do that, you're going to get the concentration of H3O plus is going to be about 0.18 molarity. All right, so that's how you would find that. And the same thing goes here. What if we're given H3O plus, the concentration of H3O plus, and how do we find OH? Well, again, guys, this is pretty easy. All you do is the opposite, right? So we have our Kw, right, which is OH minus times, sorry about that, let me go and write that better, OH minus times our H3O plus concentration. But then we already know this, so it's just, that's half the battle, right? And so all we have to do is just feed it in. So 1.0 times 10 to the negative 14th equals our OH, which we're trying to find, the concentration of OH, and we're already given the H2O plus concentration, 6.7 times 10 to the negative 8th, all right? And then we just solve for OH like you would do in a regular algebraic equation, all right? So OH is equal to about 1.49 times, oops, dang it, I can't write today either, 1.49 times 10 to the negative 7th molarity. All right, and that's pretty much it. So that's how you would use the Kw, ionization constant of water, right? The auto-ionization of water. Dang, I really have trouble saying that word, I don't know why. But that's it for this video. It was a short video just to get the overview, but we'll be using these steps that we have in these small videos throughout in order to solve titration problems, all right? So see you guys in the future videos where I'll talk about more cool topics. I hope to see you guys in the future videos where I'll talk about more cool topics about biochem, physics, and chem. Don't forget to hit that notification bell, like, and subscribe. See you guys later, and stay safe.